today's lesson is on the introduction to the unit circle. So we're going to talk about just the very basic things about a unit circle and what it is. So the objective is to identify and use the reference angle to construct related triangles in the unit circle. Okay, so a couple of things you guys got to keep in mind. We are going to learn about the reference angle, and we are going to learn how to create the related triangles. Okay, so we talk about a unit circle, but we are creating triangles. All right, so first of all, the definition of a unit circle is a circle whose center is at the origin and the radius is 1. So let's move on here. So here is my coordinate plane, and we were talking about the center is at the origin. We're talking about the origin of the coordinate plane. So here is our circle. The radius is 1, right? So every of these radii here on the coordinate plane, they're all 1. Okay. So you go around and you see every radius is 1. And it doesn't have to be on the x and the y axis, any radius. Okay. On the unit circle, the idea is that we want to find points on the unit circle. Okay, we want to find the x and the y coordinate on the unit circle. So the first 4 points that are the easiest are the ones on the x and the y axes. Okay, so some of you guys might be thinking, oh, I know what they are already. Okay, that's good, that's great. Okay, if you don't, let's just break it down a little bit. Okay, if you want, let's talk about the one on the right here. Okay, if you want the x and the y of the point on the right, you see the x distance, right, going to the right is 1. So my x coordinate is going to be 1. Okay. Now the y coordinate is the going up and down. Okay. Did that point go up or down at all? Actually, no, right? It went up or down 0. So my y coordinate is 0. And you can do the same thing with the other 3 points with the same logic, and comes out to be that way. Like the point on top is 0, 1, because you don't go to the left, you don't go to the right. You stay 0 on the x, but you go up 1 for the y. Same idea for the one on the left and the one at the bottom. Okay, so -1 and 0 for the one on the left, and the bottom you have 0, -1. Now, if we're talking about any point on the unit circle, now imagine if they give you like a random angle. Okay, so they give you an angle, and you go according to the angle, and you approach the circle, and then you're wondering, how do I find the x and the y coordinate for that point? Okay, well, if you want the x and the y coordinate for that point, you can look down on the x axis, and that'll give you your x, and you look to the left to the y axis, and that'll give you your y. Okay, you just have to find out what those values are, basically. And the idea is this is what we do with the unit circle. Okay, the idea is that we make a triangle drawing toward the x-axis. Okay, now remember, for the sake of uniformity, we're all going to always draw toward the x-axis, not the y-axis. Okay, draw toward the x-axis. So I have that triangle there, and if I draw straight down, you guys know if it goes straight down, it's going to make a right angle with the x-axis, so it becomes a right triangle. And now the base of that right triangle is your x, right? Because that's the distance going on the x-axis, right? And the height of the triangle is your y. So if you can find the base and the height of that triangle, you get your x and your y, the coordinates of that point on the unit circle. Okay, so we can do that pretty easily. Taking that triangle and using our sine, cosine, tangent, we can find the x and the y, because we know that the radius is 1, right? Because the radius of the circle is 1. So that gives you the hypotenuse of the triangle is 1. Okay, now we're not going to go in that deep today. Today we're just basically going to construct that triangle. That's all we're going to do. So before we go further, these are the couple of vocabulary that you guys want to write down. Okay, terminal side. So in the triangle, you have the base and the height, and the terminal side is the hypotenuse. So terminal side is the hypotenuse. Okay, So terminal side, hypotenuse of the triangle. The other vocabulary is the reference angle. Reference angle is the angle formed by the terminal side and the x-axis. So in this case, it's the 57. Okay. So when the triangle is in the other quadrant, it will look a little bit different. Okay. So you guys have to keep in mind it's the angle formed by the terminal side, which is the hypotenuse, and the x-axis. Let's move on and do a couple examples here. The first example I have is the angle 74, and we are going to find the reference angle and construct the triangle. All right, so let's draw that angle 74. You guys should know by now 74 is somewhere there in the first quadrant, less than 90, more than 45. Okay, so 74 is there. Now what do? We go to the point on the unit circle and we draw toward the x-axis. Okay, never draw toward the y-axis. Okay, so draw toward the x-axis, and there I have my my little triangle there. You see, so there's the triangle. That's the triangle that's going to help me find the coordinate on the unit circle. But I won't need to do that now. Okay, that's all I need to do is make that triangle, and the reference angle is the angle between the hypotenuse, okay, terminal side, and the x-axis right there. So it's going to be 74. Okay, that angle 74 is my reference angle. Example part B, I have angle 125. So 125 is somewhere over there. Okay, more than 90, less than 180. So it's there, 125. And to make the triangle, I draw toward the x-axis. So draw. Ooh, see that? That is a mistake, right? Should I ever draw toward the y-axis like that? No, never. Okay, don't do that. Okay, that's a mistake. Okay, you draw toward the x-axis like that. Now I have my triangle. Then I need to find the reference angle. Now the reference angle is the angle that is formed by the terminal side, which is the hypotenuse, and the x-axis, right? So it's the angle inside the triangle here. Not the 125, but the one over here in the triangle. So how do I do that? Well, I know the whole way. Oh, there you go. I need to look for that x, basically. And then the whole way is 180, and the 125 is already there. I need to subtract 125 from 180 to find the angle x is 55. Okay. Example part C is 247, and it happens to be there, 247, right there. Right, now I draw toward the x-axis. So you could draw up, you could draw down, but never sideways. Then I have my triangle. Then I need to find my reference angle there, the x. Okay, the reference angle is the angle inside the triangle between the hypotenuse and the x-axis. So I gotta know that the whole way is 147, and half a circle is 180. So the difference between 247 and 180 is my x. So I just subtract, right? 247 minus 180 equals 67. That's my reference angle. Let's move on and try radian. And you guys should know radian and how to deal with them. Now, at this point, if you feel like you want to convert radian into degrees so you can do it, I guess it's okay. It's just really, really slow. And if you want to go into trig next year, if you want to be successful in trig, you have to be comfortable with radian. So if you want to do this and prepare for trig, do it in radian. Okay, so I'm going to do it in radian. Okay, so the idea about this example is that it's negative and it's in radian. So let's work that out. Negative means we go clockwise, we go this direction. Okay, go this direction. But we have to figure out, okay, how far do we go? Now remember, pi is equal to 180 degrees. That means 180 is half a circle. This is 1 pi. That is something you guys all need to keep in mind. You have to know that a radian is like a part of that pi, right? So they give you 9 pi over 4. That means you split whatever pi you have into 4 parts. So just take pi and split into 4 parts. 1, 2, right? So 1, 2, and 3, 4. See, pi now has 4 parts. 1, 2, 3, 4. Right? 1, 2, 3, 4. That's basically how many fourths you have. So if you draw down to here, that's 1/4 pi. If you draw your angle down to here, that's 2/4 pi. To here, 3/4. To here, 4/4, which means 1 pi. If they want 1 pi, you draw that much. If they want 1/4 pi, you draw this much. And you want to go all the way around so that you get to 9/4, right? So each half a circle gives you 4, another 4 up here, right? There, that's 8 halves. 8 halves mean a whole circle. I mean, 8/4 means a whole circle. So 8/4 means 2 pi. 2 pi is a whole circle. Now they want 9/4, which means you want one more. So one more fourth. Now you end up here. Okay, so here it is. Your angle is right there. All right, there is my angle. Now you draw toward the x-axis and you have your triangle in here. This is your triangle. All right. Now, if you want the reference angle, you're looking for this part here. X right there, x degree, or in radian, whatever you want. But since they asked us in radian, let's do it in radian. Now you have to think, how big is this little angle here? We said we split our pi into fourth, right? And this one is 1 part, 1 out of 4. So my answer is 1/4 pi. That's my reference angle. But because it's going down this way, you would think that it's a negative 1/4 pi, right? Negative 1/4 pi. But the thing is, when we're talking about reference angle, we're talking about the angle inside the triangle. So it's just positive 1/4 pi, or pi over 4. Okay, reference angle is always going to be positive.